How many possible triangles? So recall sine. It's good to know how sine this function looks like. You start at 0, 0, the origin here, and draw 4 teeth. Pow. Sine goes up and goes down, and this is pi. That's pi radians, or 180 degrees. It goes down and goes up. This here is 2 pi radians, which is the same thing as 360 degrees. So we have 90 degrees, 180, 270, and 360 degrees. And memorize that sine goes up and down forever, never. It oscillates up and down. But in the context of the first 360 degrees, we're just focusing on the possible angles of this triangle. We're actually focusing on the first 180 degrees. Sine has a maximum value of 1 and a minimum value of -1. So when you're saying that the function y is equals to sine b, or y equals sine x, or y equals sine theta, whatever the x value is, in this case it's b, we know that the maximum height is 1, not 1.2. So when you say y equals 1.2, that's this part here, there's no solution. It never hits. So there's no possible triangles. Now let's try B. We have angle C is 63 degrees. So let's draw something roughly like 63 degrees. We'll label it C. And let's try to make this drawing make sense. Let's make side length a bit longer than B, because the goal is to make this 12 longer than this side here. We'll call this B. The corresponding angle B is across the side length. So this diagram may not be to scale, and there might be more than one possible triangle just because of the sine law ambiguous case. We have ASS. This diagram may not be to scale. There might be some other possibility. But let's simply use the sine law. Sine B over B, which is 9, is equals to, let's play catch, sine C over C. Multiply both sides by 9. We have sine B is approximately 0.668. So hit the sine inverse button. We get a possible B1 angle of 41.9 degrees, and always take the other possible angle is going to be 180 minus that result, which would be 138.1 degrees. Now be careful. Always beware of extraneous solutions. If indeed angle B was obtuse, 138 degrees, would that even be possible in the context of a triangle? 138 plus 63 is already greater than 180 degrees. It's impossible. The maximum angles in a triangle must be 180. We're already past it. So let's reject this possible answer. There's only one possible solution. One possible triangle. So finally, let's draw this triangle here, part C. Let's make angle C 30 degrees. This drawing is not to scale. And let's try to make this a bit shorter. We'll make this 6. We'll call this C. We'll call this, pardon me. We're going to call this C because it's shorter. We'll call this B because we're trying to match it to make sense, because B is 10 over here. Okay, so we have ASS. There could be an ambiguous case where the triangle swings over, and there could be two possible B values. So why don't we use the sine law so we can see it clearly. Sine B over B, which is across the triangle, is 10, is equals to sine C over C. Multiply both sides by 10. We have 0.83 repeater. Hit the sine inverse button and we get B1 is approximately 56.4 degrees. And we always check 180 minus this answer to get the other possible ambiguous case. So the second possible answer for this angle is 123.6. Now in the context of this question, if indeed we're talking about this obtuse angle being 123, what about the 30 degrees here? 123 plus 30 is still below 180, so this is possible. This is one possible solution. This is another possible solution, so we have two possible triangles. Now it's your turn. How many possible triangles? Try to visualize by drawing the triangles, use the sine law, try to understand what's happening here.